Hello, and welcome, dear listeners of Sleepy Science. I'm glad you are here tonight. Before we begin, remember to take a deep breath and let the noise of the day slowly fade away. If you enjoy these cosmic stories and want others to drift peacefully through the same universe of calm curiosity, please remember to like and subscribe. Tonight, we will travel into one of the most powerful and mysterious events ever seen in the universe. An explosion so vast and bright that it outshone entire galaxies. This is the story of the most powerful black hole explosion ever recorded. In the endless depths of space, black holes are known for their silence. They do not emit light. They do not reflect it. They consume everything that comes too close. They are the quiet monsters of the cosmos. Invisible, yet incredibly influential. But sometimes, even silence can break. Sometimes, a black hole creates an event so violent that it sends shockwaves across the universe. That is what astronomers discovered when they observed an explosion coming from a distant cluster of galaxies, a blast so large it defied imagination. This discovery began with something unexpected. A strange curve in the light of hot gas that surrounded a cluster of galaxies known as Ophiuchus. Astronomers using X-ray telescopes noticed that the gas around the central galaxy was not smooth. It looked as if someone had carved a gigantic cavity inside the cluster. At first they thought it might be an error, perhaps a trick of data, but as more telescopes confirmed it, they realized they were seeing the scars of something truly enormous. That cavity was not small. It was big enough to fit many galaxies inside it. To create such a structure, something had to release an unbelievable amount of energy. The only known force capable of doing this was a supermassive black hole sitting at the cluster's center. But how could something that pulls everything inward also push so much outward? The answer lay in one of the strangest and most powerful processes in the universe: the eruption of energy from a black hole's magnetic fields. You see, when a black hole feeds on matter, not all of that matter falls in. Some of it gets caught in powerful magnetic fields near the event horizon. These fields twist and spin, forming enormous jets of energy that shoot out from the black hole's poles at nearly the speed of light. Usually, these jets extend for thousands of light years and fade quietly into the cosmic background. But in this case, the jet did something much greater. It exploded with such force that it blew a hole through the galaxy cluster's gas, leaving behind a cosmic wound that could still be seen billions of years later. To understand how massive this was, imagine a blast that released hundreds of times more energy than all the stars in our Milky Way combined, over the course of its entire life. The explosion was not short either. It continued for millions of years, slowly inflating a cavity in the surrounding plasma, like a bubble growing in boiling water. The black hole at the center had essentially created the largest known explosion since the Big Bang itself, though this one was quiet, invisible to human eyes, and stretched across unimaginable distances. Astronomers compared it to other energetic events such as gamma-ray bursts and supernovae, and nothing came close. Those are violent, yes, but brief. This explosion was long, deep, and powerful beyond comparison. It was as if the black hole had taken a deep breath of gas and then exhaled with enough force to reshape a galaxy cluster. And yet, despite all this violence, there was beauty in what it left behind. The edges of the cavity glowed faintly with heated gas, and the surrounding space shimmered with light from distant stars. It was a reminder that even destruction in the universe can create patterns of astonishing elegance. When the first traces of the explosion appeared in telescope data, many scientists hesitated to believe what they were seeing. The shape of the cluster's gas seemed too strange, too large, too structured to be the result of chance. It looked as if an enormous hand had scooped a hollow space out of the heart of the galaxy cluster. Yet, there was no visible object that could have caused it. No star could have released such energy. No ordinary supernova could have carved such a vast cavity. The only possible source was the supermassive black hole sitting at the cluster's center, and that realization opened an entirely new chapter in cosmic study. To investigate the mystery, astronomers began combining data from multiple observatories. The Chandra X-ray Observatory, the XMM Newton satellite, and radio telescopes around the world worked together like pieces of a puzzle. X-ray images revealed the hot gas filling the cluster, while radio signals traced the patterns of invisible jets spreading through it. When the images were combined, the shape of the cavity became clear. It was not random, not chaotic, but symmetrical, as if sculpted by a powerful and steady stream of energy bursting from the black hole's poles. That symmetry was the key. It showed that this was not a single explosion like a bomb going off, but a continuous eruption, a slow, unstoppable outflow of energy that lasted for millions of years. The black hole had drawn in matter from its surroundings, compressed it, and then funneled some of it out through magnetic jets. Those jets pushed against the surrounding gas, inflating two gigantic lobes like bubbles in a cosmic ocean. As the bubbles grew, they displaced trillions of tons of plasma, leaving behind vast, curved voids visible even across intergalactic distances. Measuring such an event was not simple. The distances were immense, and the light reaching us had traveled through time itself. The signals we now receive began their journey when our planet was still young, when mammals were only beginning to walk the Earth. To measure the size and power of the explosion, scientists calculated the energy required to lift that much gas against the gravitational pull of the cluster. The result was staggering, more energy than any other known process in the universe, apart from the Big Bang. And yet, despite the scale, the process followed simple physics. Energy must go somewhere. When matter falls into a black hole, it heats up, it spins, and it releases radiation. Most of the time, that energy escapes as faint jets or small bursts, but sometimes, under the right conditions, the system becomes unstable. The magnetic fields twist, and a chain reaction begins, focusing enormous power into a narrow beam. When that beam meets the surrounding gas, it expands explosively, carving through the medium like fire through air. As scientists reconstructed this process, they realized that the explosion was not just destructive, it was creative. By pushing gas outward, it prevented the core of the cluster from cooling too quickly. If it had not happened, the gas would have condensed, forming thousands of new stars and altering the balance of the galaxy. The black hole, often imagined as a destroyer, had acted like a cosmic regulator, controlling the flow of energy in its environment. The images that resulted from this study were hauntingly beautiful. Against a background of faint galaxies, the ghostly cavities glowed in soft shades of blue and violet. Around their edges, clouds of heated gas shimmered like halos. To see such balance, such order emerging from chaos, reminded scientists that even the most violent cosmic forces follow rules, and that within the universe's fury, there is structure and meaning. As the data became clearer, astronomers understood that they were witnessing one of the largest controlled energy releases in existence. The black hole had not destroyed its home, it had reshaped it. The explosion was a statement of balance, a reminder that even in the darkest corners of the universe, creation and destruction are the same act viewed from different sides. At the center of the Ophiuchus galaxy cluster lies a black hole so immense that ordinary words fail to describe it. It is not just large, it is colossal. A gravity well so deep that even light cannot climb out. Around it swirls a vast disk of gas and dust, glowing from friction and heat, spiraling closer and closer until it disappears into darkness. This is where the story of the explosion truly begins, inside the heart of the monster. Black holes form when massive stars reach the end of their lives and collapse under their own gravity. But this black hole is different. It did not come from a single star. It is the result of countless mergers, each one adding to its mass, each one deepening its pull. Over billions of years, it grew into a supermassive being, sitting at the center of its galaxy like a silent ruler. Around it, billions of stars orbit, each one a captive of its invisible influence. Yet, for all its power, a black hole is not a vacuum cleaner that simply swallows everything nearby. It is more subtle, more balanced. Matter must fall toward it, but before it crosses the event horizon, that final point of no return, it forms a swirling disk called an accretion disk. In that disk, gravity and friction transform matter into energy. Particles collide, heat builds, and the energy radiates outward in streams of light and plasma. The faster the material spins, the more intense the radiation becomes, until magnetic fields begin to twist and coil around the black hole like a storm of lightning. From these magnetic storms emerge the black hole's jets, narrow, focused beams of energy that shoot out from its poles. They move at nearly the speed of light, carrying with them charged particles, radiation, and magnetic fields. These jets can travel for millions of light years, cutting through intergalactic space like glowing spears. They are both magnificent and terrifying, silent arrows of destruction and creation combined. In most galaxies, these jets are stable. They flicker, fade, and flare, but they do not explode. However, the black hole in Ophiuchus gathered so much material so quickly that its balance broke. Too much gas fell inward at once, feeding the accretion disk until its magnetic field snapped under the pressure. When that happened, the stored energy released in a single colossal burst. The result was the cosmic explosion, a silent detonation that sent shock waves through space and carved the immense cavity we see today. To picture this, imagine a volcano beneath an ocean of gas. For countless years it lies quiet, building pressure deep below. Then, one day, it erupts. The force tears through the water, sending ripples that reshape the entire sea. The Ophiuchus black hole eruption was much the same, but on a scale beyond comprehension. It released a storm of energy so vast that even billions of years later, the waves of that eruption still echo through the cluster. And yet, if we could have stood near it, we might not have seen much at all. The jets in the explosion were mostly invisible to human eyes. They glowed in X-rays and radio waves, far beyond the range of normal vision. The visible sky around it might have looked calm, while in reality, an unseen storm of unimaginable power was unfolding. The black hole itself, of course, remained invisible. No matter how bright the explosion, its center stayed black. It did not shine. It did not move. It simply remained, silent and eternal, while the universe around it roared. What fascinates scientists most is how something defined by absence, by the inability of light to escape, can produce such radiant displays. The answer lies not inside the black hole, but at its edge, where matter fights its last battle against gravity. It is there, in that thin boundary between being and nothingness, that creation happens. Long after the explosion ended, its presence remained written across space like a memory carved into stone. The Ophiuchus cluster still bears the mark of that unimaginable eruption, a faint, glowing scar stretching through the hot gas that fills the space between galaxies. Though the blast itself happened billions of years ago, the echo of its power continues to ripple outward, slowly changing everything it touches. Astronomers studying the cluster today can still see the shock waves. They appear as curved ripples in the X-ray images, smooth arcs of energy sweeping through the intergalactic medium. These ripples move slowly by cosmic standards, but their scale is enormous, extending across hundreds of thousands of light years. Each ripple is a frontier between hot and hotter gas, a boundary formed where the pressure from the explosion met the resistance of the surrounding space. The sound waves from that blast would have been so deep and so long that if we could somehow hear them, one single vibration would last for millions of years. The universe itself hums with such low frequencies, tones too vast for human perception. It is a cosmic song played in slow motion, a melody of expansion and energy that never truly stops. Even now, the gases in the Ophiuchus cluster are settling back into balance. The explosion did not destroy the cluster. It merely rearranged it. The jets from the black hole pushed gas away from the center, creating empty cavities that later filled with fainter radiation. These cavities, though vast, act as stabilizers. They prevent the central regions from cooling too quickly, which in turn stops new stars from forming too fast. Without such regulation, the cluster might have collapsed inward, forming bursts of star creation that would burn through its fuel too soon. In this way, the black hole acted not as a destroyer but as a caretaker. Its explosion distributed energy evenly across the cluster, keeping the environment stable for billions of years. It is a strange kind of balance, destruction creating harmony, chaos creating order. The more scientists study it, the clearer it becomes that the black hole's outburst was not just a violent event, but a necessary one. It was the universe maintaining itself. What remains visible to us now are the traces of heat, faint streams of gas glowing in the darkness. Radio telescopes reveal vast lobes of radiation stretching from the cluster's core, relics of the jets that once pierced the intergalactic medium. These lobes are ghostly and quiet, but they tell a story that bridges the past and the present, a story of energy transformed but never lost. Every particle of that explosion still exists somewhere. The electrons that once sped through the jets at nearly the speed of light are still out there, drifting, cooling, slowing. The magnetic fields that guided them are weaker now, but still present. Even light from the event, stretched and softened by the expansion of space, continues to travel, carrying the faint signature of what once was. It reminds us that nothing in the universe truly disappears. Energy changes form, matter rearranges, light stretches into silence, but everything that ever existed leaves behind an imprint. The Ophiuchus explosion may have faded from sight, but its effects remain everywhere within the cluster, influencing how it breathes, how it glows, and how it will evolve in the distant future. As astronomers continue to observe, they find that the ripples of this ancient blast help us understand our own galaxy as well. The Milky Way, too, shows signs of smaller outbursts from its central black hole, faint echoes of a quieter but similar process. It seems that explosions like these are not rare accidents, but part of the cosmic rhythm, the way black holes give energy back to their surroundings. The universe, vast and seemingly still, is always moving, always echoing its own history. Every burst of light, every flare, every ripple in space is a note in a song that never ends. The Ophiuchus explosion is just one of its deepest chords, still resonating through the fabric of time. To understand the full power of the Ophiuchus explosion, astronomers had to measure something that could not be seen directly. The blast left behind no fire, no visible light, only faint traces of heat and radiation scattered through an ocean of gas. Yet from those traces, scientists could reconstruct the entire event. Its energy, its scale, its impact on space itself. The key to unlocking this mystery was the balance between gravity and pressure. In a galaxy cluster, gravity pulls inward, holding hot gas close to the center, while energy from black holes and stars pushes outward, keeping the gas from collapsing. This delicate balance determines whether the cluster remains calm or erupts into chaos. When astronomers looked at Ophiuchus, they found that something had tipped that balance long ago, something powerful enough to move entire clouds of gas across millions of light years. Using X-ray telescopes, they mapped the temperature of the cluster's gas Y. Where the explosion had occurred, the gas was cooler and more diffuse, while regions just outside the cavity were hotter, compressed by the blast. By calculating the difference in temperature and density, scientists estimated how much energy was needed to create the cavity. The result was astonishing. The explosion released more energy than hundreds of thousands of supernovae combined, all over a span of millions of years. But the black hole did not act randomly. Its eruption had purpose. It was restoring equilibrium. If too much gas gathered in the cluster's center, it would cool and collapse into new stars, which would quickly burn their fuel and die. The explosion prevented that by reheating the gas, spreading energy outward like a cosmic heartbeat. This process, known as feedback, is one of the most important self-regulating mechanisms in the universe. It ensures that galaxies do not burn too fast or fade too soon. What makes this discovery even more remarkable is how it connects the smallest and largest scales of existence. At the core of the explosion was a single black hole, perhaps only as large as a few times the size of our solar system. Yet, the energy it released shaped a region larger than many galaxies combined. It is a reminder that in the universe, size does not always equal influence. Sometimes, the smallest things control the fate of the largest. As astronomers traced the shockwaves outward, they found more subtle effects. The gas in the cluster moved in gentle flows, spiraling slowly around the cavity like water around a stone. These movements revealed how energy travels through space, not as chaos, but as waves of motion, graceful and continuous. Even destruction in the cosmos follows patterns of beauty. Radio telescopes added another layer to the picture. They detected the fading glow of particles accelerated by the explosion. These faint radio signals mapped out the invisible magnetic fields still swirling around the cavity. Together, the radio and X-ray data formed a perfect image of balance, gravity pulling in, pressure pushing out, the two forces dancing in harmony across millions of light years. Scientists began to see black holes not as devourers but as regulators of creation. Without their eruptions, galaxies would grow unstable, collapsing, or burning out. With them, the universe maintains its rhythm. Every explosion, every jet of energy, every ripple of radiation plays a role in the cosmic equilibrium. In this sense, the Ophiuchus event is not just the story of destruction. It is a story of balance, of how even the most violent acts of nature can sustain harmony. The black hole did not simply explode. It breathed energy into its surroundings, ensuring that the galaxies around it could continue to exist. When we look at the data, we are not just seeing light from a distant past. We are seeing the physics of life and death on a cosmic scale. The same forces that shape stars, planets, and perhaps even the conditions that allow life to begin. When astronomers compared the Ophiuchus explosion to every other cosmic outburst ever recorded, they realized that nothing else even came close. Supernovae, gamma-ray bursts, and quasars, all of them, though incredibly bright and powerful, were small beside this colossal event. It was as if an entire galaxy had flared up at once, releasing more energy than countless stars combined. To put this into perspective, imagine every star in the Milky Way shining at full brightness, then multiply that light by hundreds of thousands. Even that would not equal the energy this single black hole released. The difference was not only in scale, but also in duration. A supernova lasts a few weeks, a gamma-ray burst perhaps seconds. But this eruption continued for millions of years, a slow and steady storm of unimaginable strength. Astronomers studying this event described it as the largest known explosion since the birth of the universe. The black hole did not simply flare up and fade, it exhaled. The jets that burst from its poles carved tunnels through the gas of the cluster, pushing it aside like waves breaking through fog. The space that opened around those jets became enormous cavities, each one larger than the Milky Way itself. The heat and pressure from this explosion reshaped the cluster's structure. The hot plasma that filled it was displaced, compressed, and mixed. The surrounding regions brightened in X-ray images, glowing from the shock. It was a display of power on a scale almost beyond human imagination, yet it followed the same laws of physics that govern the simplest acts of motion on Earth. Energy moved, pressure built, and balance returned. In this way, The universe shows that scale is only a matter of perspective. The same patterns appear everywhere, in a ripple across a pond, in a storm over an ocean, in an eruption from a black hole billions of light years away. The forces are the same, only the magnitudes differ. The explosion also revealed something profound about the role of black holes in the cosmos. They are not silent voids but engines, cosmic power plants that drive the evolution of galaxies. The energy released from this single event was enough to prevent the cluster's gas from cooling and forming new stars for eons. Without it, the cluster would have changed dramatically, perhaps forming countless new suns that would later die in chaos. Instead, the eruption kept the system stable, spreading heat evenly through space like a vast invisible hand guiding its destiny. The brightness of the event could not be seen in ordinary light. To the human eye, the region might appear dark and calm, but in X-ray and radio wavelengths, it was radiant, glowing like a beacon in the cosmic sea. These hidden frequencies reveal the true face of the universe, showing that most of its beauty lies beyond what we can see. Scientists sometimes call such events cosmic feedback, but that phrase hardly captures the grandeur of what happens. It is more like the heartbeat of creation itself, the push and pull that keeps galaxies alive. When a black hole erupts, it is not only releasing energy, it is maintaining harmony. It prevents stagnation, spreads balance, and ensures that matter and energy continue to circulate through the universe. And though this explosion was the most powerful we have yet recorded, it may not be the largest that ever happened. Somewhere beyond our reach, beyond the light we can see, there may be even greater eruptions unfolding right now. The universe is vast enough to contain infinite variations of power and silence. What we have seen is only one glimpse, a single note in an endless cosmic symphony. As you imagine that explosion, try to see it not as destruction, but as movement. A slow and graceful act of cosmic balance. The black hole at its center remains still, but everything around it dances to its rhythm. The energy flows outward, shaping galaxies, shaping time itself. When we look into space, we are not just looking into distance. Every ray of light that reaches Earth began its journey long ago, crossing billions of years before touching our eyes or the sensors of a telescope. For astronomers, this is not a limitation, it is a gift. The light that travels through the universe carries messages, faint signatures that reveal what happened long before humanity existed. Through this light, we can read the history of creation itself. The Ophiuchus explosion is one of those ancient messages. The radiation that reveals its story began its journey before our solar system had even formed. It moved across expanding space, its wavelength stretched and softened until it finally arrived here, where instruments could decode it. By studying this light, astronomers can reconstruct events that no living being could have witnessed. They do this by capturing different kinds of light, X-rays, radio waves, infrared signals, and visible light, each one telling a different part of the story. X-rays reveal the hottest regions of the cluster, where gas glows with millions of degrees of heat. Radio waves show the movement of charged particles, tracing the invisible jets that erupted from the black hole. When combined, these data form a complete picture of both energy and motion, allowing scientists to see what the human eye cannot. In X-ray images, the heart of the explosion appears as a dark void surrounded by glowing arcs of gas. In radio images, the same region shines brightly, filled with the faint echoes of ancient particles still moving through magnetic fields. Together, they describe a single event that unfolded over millions of years, a burst of power that reshaped an entire region of space. The beauty of this discovery lies not only in what it shows, but in how it shows it. Every pixel of light captured by a telescope is a piece of the past, preserved across time and distance. The universe records itself through its own radiation, each particle of light carrying the memory of where it came from. Astronomers become readers of that record, translating its patterns into understanding. But the light also changes as it travels. Space is not empty. It stretches and expands, and as it does, it pulls the light with it. This stretching turns short, powerful wavelengths into longer, softer ones, a phenomenon known as redshift. That is why the energy from the Ophiuchus explosion reaches us not as a blinding flash, but as a whisper of warmth, a faint echo of what it once was. The expansion of the universe transforms violence into calm, chaos into silence. Even through that silence, the signal endures. The faint glow, seen by modern telescopes, is still enough to reveal the temperature, density, and motion of the cluster's gas. It tells us how far the shockwave traveled, how long it lasted, and how it changed the structure of the surrounding space. From these clues, astronomers can even estimate how much matter the black hole consumed to fuel the eruption. A story told entirely through light that has been traveling for billions of years. This is one of the quiet miracles of science. The ability to take invisible signals and turn them into a picture of reality. The light that arrives at our instruments is unimaginably weak, yet through patience, precision, and imagination, we can transform it into knowledge about the most powerful forces in existence. When you think about that, it becomes clear how deeply connected we are to the universe. The light we study is not just something outside of us. It is the same light that warms our planet, that powers life, that defines time itself. Every photon that enters our eyes is a direct link between us and the cosmos. We are made from the same energy that we observe. As astronomers continue to read the light of the Ophiuchus explosion, they find not just information, but meaning, a reminder that the universe is both ancient and alive, still sending its messages across time to anyone willing to listen. Black holes are often described as silent, as if their nature were defined only by absence. Yet in truth, they are among the greatest storytellers in the universe. Each one shapes its surroundings, leaves marks in light and motion, and records its history in the patterns of the galaxies it touches. The Ophiuchus black hole, with its colossal eruption, is one of those storytellers, a being that speaks not in words or sound, but in waves of energy that echo through space for billions of years. When astronomers look at a galaxy cluster, they can read the story of its central black hole in the shapes and movements of the gas around it. The cavities carved by past eruptions, the jets of radiation that stretch like threads through the void, even the temperature gradients in the plasma, all of these are lines in a cosmic diary. The Ophiuchus explosion is a chapter written in fire and silence, a record of a time when darkness created light. The story begins deep within the gravitational heart of the cluster, where gas slowly spiraled inward for millions of years. As it fell, it grew hotter and denser, until the pressure around the black hole became unbearable. Then, with a sudden release, the system exhaled. Jets erupted, cavities formed, and the surrounding gas was hurled outward. The black hole, though invisible, left behind a signature that could never fade. This pattern has repeated across the universe countless times. At the center of nearly every galaxy lies a black hole, and each one shapes its host in a similar way. Without them, galaxies would grow uncontrollably, forming too many stars, burning through their gas too quickly. With them, the energy released from their eruptions spreads stability. The black hole, in a sense, is both the heart and the mind of its galaxy, regulating its rhythm, guiding its evolution. The Ophiuchus cluster shows this balance perfectly. The explosion that once seemed violent is now understood as a part of the natural order, a conversation between gravity and pressure, between creation and destruction. The black hole did not act in chaos. It acted in harmony. By releasing its energy, it allowed the cluster to breathe again. To understand this process, imagine the universe as a vast, living organism. Galaxies are its cells, stars are its molecules, and black holes are its pulse. Each heartbeat sends energy through space, ensuring that everything remains alive and in motion. The eruption in Ophiuchus was one such heartbeat, powerful enough to echo across time. Even now, the cluster continues to evolve under the influence of that event. The gas that was once expelled is slowly drifting back toward the center. Over billions of years, it may cool again, and when it does, the black hole will feed once more. Perhaps another explosion will come, smaller or greater, and another chapter will be written in the story of the cosmos. This endless cycle of feeding and releasing defines the relationship between black holes and galaxies. It is a conversation written in light and shadow, a balance maintained through energy. It is also one of the reasons the universe has remained structured for so long. Without these regulating eruptions, galaxies would have burned out long ago. Instead, the cosmos remains dynamic, always changing, always self-correcting. As we listen to the story of Ophiuchus, we are reminded that even the darkest places in the universe are not lifeless. They are full of motion, memory, and meaning. The black hole's explosion was not the end of something. It was a message, a whisper from the universe itself saying that balance comes even from destruction, that silence can speak louder than light. When we imagine space, we often think of emptiness, a quiet void scattered with distant stars. But space is not empty at all. It is filled with invisible matter, with energy, with movement. Every explosion, every burst of light, every breath of radiation shapes it like wind shapes the surface of sand. And among the greatest sculptors of this cosmic landscape are black holes. The Ophiuchus explosion is a perfect example of this. It did not just release energy, it reshaped the space around it. The hot gas that filled the galaxy cluster was pushed outward, forming enormous cavities. These cavities are not static. They expand, contract, and interact with the surrounding material, changing the cluster's structure. They are like ripples on a pond, except that each ripple is the size of entire galaxies. When scientists studied these structures, they realized that black holes do not simply influence their immediate surroundings. Their energy travels outward, stirring the intergalactic medium, the thin plasma that fills the spaces between galaxies. The Ophiuchus eruption sent waves of motion through that plasma, waves that are still moving even now, long after the explosion ended. These waves carry heat, magnetism, and information, slowly sculpting the cluster's shape and balance. This process reveals something profound about how the universe maintains order. The gas in a galaxy cluster tends to cool over time, sinking toward the center and forming new stars. If this cooling continued unchecked, the cluster would eventually collapse into a dense core. But when a black hole erupts, it sends out enough energy to reheat the gas, stopping the collapse. The result is a cycle: cooling and heating, compression and release, silence and eruption. This cycle keeps the structure of the cluster stable over billions of years. In Ophiuchus, this cycle reached its most powerful form. The explosion was so immense that it sent shock waves through space, creating what scientists call sound waves. Though they travel not through air, but through plasma. These waves move so slowly that one full oscillation could take millions of years. It is the deepest, lowest sound in the universe, a tone so vast that it can never be heard by human ears, yet it vibrates through space continuously, a reminder that even emptiness has its own music. When we observe these patterns, the ripples, the waves, the heat, we begin to see that space is not a blank canvas. It is a living texture. Every galaxy, every star, every explosion leaves its mark. The black hole in Ophiuchus carved its mark deeper than most, creating a lasting monument to power and balance. Even the magnetic fields that surround the cluster were affected. The jets that once erupted from the black hole twisted those fields into new shapes, aligning them, strengthening them. Those invisible lines of magnetism now stretch across the cluster, guiding the motion of particles and shaping the way radiation moves. The explosion did not end with light. It continued through magnetism, through structure, through geometry itself. In this way, black holes act as cosmic artists. They do not paint with color, but with motion, heat, and gravity. Their tools are pressure and time. Their canvas, the vastness of space. The patterns they create, cavities, jets, ripples, and waves, become part of the architecture of the universe. When we look at the Ophiuchus cluster now, we are seeing not just the aftermath of a violent event, but the sculpture it left behind. The gas glows softly in X-ray images, shaped by the contours of the explosion. The radio lobes stretch like faint wings, still whispering with the echoes of ancient energy. It is a work of art on a scale beyond imagination, not made by intent, but by the natural laws that govern everything from atoms to galaxies. As we understand these processes, we begin to see that the universe itself is not random. It is structured by the very forces that seem most chaotic. The black hole's explosion was not disorder, it was design. A design born from gravity, heat, and motion. A design that gives shape to the infinite. When people first hear the word explosion, they think of destruction, of endings, of things broken apart. But in the universe, explosions often do the opposite. They create. They shape new beginnings out of the remains of what came before. The Ophiuchus black hole eruption, though vast and violent, was also an act of creation on a cosmic scale. It scattered matter, stirred energy, and changed the destiny of countless stars yet to be born. Inside a galaxy cluster, the gas that fills the space between galaxies acts as the raw material for star formation. When that gas cools, it collapses under gravity and forms new suns. But if it cools too quickly, stars form in great numbers, burning bright and dying young, leaving chaos behind. The Ophiuchus explosion changed that rhythm. By pushing and heating the gas, it slowed the process, allowing the cluster to evolve gently instead of collapsing in a burst of uncontrolled starbirth. The energy from the explosion traveled through the cluster like wind through clouds, mixing the gas and spreading it evenly. That motion prevented the gas from gathering too densely in one place, keeping the system balanced. Over millions of years, this movement created regions of warmth and stability, places where new stars could form slowly and steadily. In this way, the black hole, a symbol of gravity and darkness, became a silent gardener, cultivating balance in the galaxies that surrounded it. But its influence reached even farther. The jets of plasma that erupted from the black hole carried magnetic fields and high-energy particles into intergalactic space. Those particles became seeds, tiny sparks that later helped shape the birth of new stars. In the universe, magnetic fields play a key role in gathering matter. They guide gas into clumps, helping it collapse into glowing spheres of light. So when the Ophiuchus black hole erupted, it not only cleared and heated the space around it, it also planted the invisible framework for future stars to form. This pattern repeats everywhere in the cosmos. When stars explode as supernovae, they scatter elements into space, creating the material for new generations of stars and planets. When black holes erupt, they distribute heat and magnetic energy, guiding where those new stars will form. It is a cycle of creation born from destruction, a rhythm that keeps the universe alive and changing. If we could watch the Ophiuchus cluster over billions of years, we would see this process play out like a slow symphony. The explosion fades, the gas drifts, cools, and gathers again. Small galaxies within the cluster begin to form new stars, faint glimmers of light returning to the darkness. The black hole sleeps for a time, quiet and still, until one day it awakens again, fed by the very matter its last eruption set in motion. Then the cycle begins once more. What makes this beautiful is not just the scale, but the purpose that emerges from it. There is no chaos that does not lead to order, no destruction that does not create something new. The black hole may seem indifferent, yet it maintains balance more perfectly than any design could. It releases energy only when needed, shaping the environment around it so that the cluster can remain stable for billions of years. Astronomers sometimes call this process feedback, but in truth, it is something deeper, a conversation between the universe's forces. Gravity pulls, pressure pushes, heat rises, and motion spreads, all in a constant exchange that ensures life continues on cosmic scales. From that exchange comes everything we see. The stars in the sky, the planets beneath them, and even the atoms within us. The Ophiuchus explosion is a reminder that creation and destruction are not opposites. They are partners. They work together to shape the universe, to recycle its energy, to build and rebuild across eternity. The stars that shine in distant galaxies today may owe their existence to explosions like this, ancient events that gave structure to the darkness long before our world was born. As you imagine this, think of how quiet it must be now in that cluster. The explosion long gone, the gas drifting in silence, the stars forming one by one in its wake. Out of the most powerful blast ever recorded, peace has returned, and from that peace, new light is beginning to grow. Every explosion leaves something behind, not only emptiness but potential. The Ophiuchus eruption, though ancient, gave birth to that potential in the form of new light. The gases it scattered across space did not vanish. They drifted, cooled, and began to condense into clouds that would one day give rise to new stars. These newborn suns are the children of that long-fated cosmic storm, carrying in their very atoms the energy once released by the black hole's fury. When we look at the stars that now shine within the Ophiuchus cluster, we are seeing the echoes of that explosion transformed into light. The matter that the black hole expelled slowly gathered again, drawn together by gravity and guided by the invisible threads of magnetism that stretched across space. Over millions of years, small pockets of gas grew dense enough to ignite nuclear fusion, turning darkness into warmth. Each new star that formed was a small act of renewal, a spark born from what seemed like devastation. The process is delicate. Too much heat, and the gas cannot collapse. Too little, and it falls inward too fast. The explosion balanced those extremes perfectly, heating the cluster just enough to control the pace of creation. The result is a quiet field of new stars, glowing softly in the dark, their lives measured in billions of years. These stars are younger than the black hole that shaped them, yet they owe their existence to its ancient violence. The beauty of this cycle lies in its harmony. The black hole, often thought of as the end of all things, becomes a source of new beginnings. The energy it releases prevents chaos and gives order to the process of formation. Without such regulation, the cluster would have collapsed under its own weight. Instead, it remains alive, breathing through the slow rhythm of heating and cooling, creation and rest. Even the planets that may one day form around those new stars will carry traces of that explosion. The heavier elements, carbon, oxygen, iron, and others, were created in earlier generations of stars, then scattered across the cluster by eruptions and supernovae. The Ophiuchus blast helped spread those elements evenly, ensuring that future systems would have the ingredients needed for planets, and perhaps even life. In a way, the black hole helped prepare the environment for new worlds to arise. It's strange and humbling to think that such beauty can come from something so destructive. Yet the universe always follows this pattern. Chaos births order, darkness births light, and silence eventually gives way to sound. The Ophiuchus explosion is one of the grandest expressions of that rule, the universe's way of creating balance through motion and change. If we could stand inside the cluster now, the view would be serene. The glowing gases would form faint, colorful clouds stretching across the sky. New stars would burn quietly, their light diffused through veils of dust. In the distance, the vast cavities left by the explosion would hang like shadows, reminders of the power that once moved through them. There would be no sound, no violence, only the calm breathing of space as it rebuilds itself. This is the paradox of the cosmos, that its greatest storms leave behind its greatest peace. The energy released by the black hole did not vanish. It simply changed form, becoming warmth, light, and structure. The cluster continues to evolve, and though it may take billions of years, the legacy of that explosion will remain in every star that shines there. Each of those stars is a testament to the unity of creation and destruction, a small piece of the story written across the universe. And somewhere within that cluster, the black hole still waits, quiet, patient, gathering matter once more. When the time comes, it will awaken again, and another wave of energy will shape the cosmos anew. In the quiet heart of nearly every large galaxy, a black hole waits. Most of the time, it sleeps. No light escapes from it. No great jets of energy rise from its poles. Around it, stars continue to orbit in perfect silence, unaware that they circle a force so powerful that it could one day reshape their entire world. These are the sleeping giants of the universe, vast, patient, and eternal. The black hole in the Ophiuchus cluster now rests in that kind of slumber. After releasing an explosion so powerful that it changed the structure of its galaxy cluster, it has returned to stillness. The gas around it has thinned, the magnetic fields have calmed, and the jets have faded. From a distance, it appears peaceful. Yet this peace is not permanent. It is only a pause in an endless cycle of hunger and release. Black holes feed on the matter that drifts too close. Clouds of gas, wandering stars, even smaller black holes. When that matter is plentiful, it forms a bright accretion disk around the black hole, and energy bursts outward in streams that light up space. When the supply runs out, the black hole falls silent again. This rhythm can last for billions of years, repeating endlessly. Each awakening sends ripples through the cosmos. Each period of sleep allows space to settle once more. The Ophiuchus explosion was one of those awakenings, a moment when the balance tipped, when the black hole consumed too much matter too quickly and could no longer contain its own energy. The outburst that followed spread through space like a slow-motion thunderclap. Now, having released that energy, the black hole sleeps again. The region around it glows faintly from the heat left behind. But the storm itself is over. This cycle of activity and rest defines how galaxies live and grow. A black hole's eruption might seem rare, but over cosmic time, it happens often enough to shape the destiny of its host galaxy. Each explosion prevents the surrounding gas from collapsing too soon, ensuring that star formation continues at a balanced pace. The result is a galaxy that survives longer and evolves more smoothly. Even in sleep, the influence of a black hole never ends. Its gravity still controls the motion of stars in the central region. Its magnetic fields still shape the space around it. It is a silent anchor, holding the galaxy together through time. The same is true for the Ophiuchus cluster. Even though the black hole now rests, its presence defines everything. Astronomers often describe these sleeping giants as quiet engines, their power hidden beneath calm exteriors. If we could somehow watch the black hole's surroundings over billions of years, we would see subtle signs of its dreams. Streams of gas would drift inward like slow rivers. Magnetic fields would twist and shimmer. Heat would build, and then, without warning, the stillness would break. The black hole would awaken, and space itself would tremble once more. What is remarkable about this process is how natural it is. There is no randomness in it. No chaos, only rhythm. The universe breathes through these cycles. Energy flows in and out, shaping everything from the smallest particles to the largest galaxy clusters. The Ophiuchus explosion is just one breath in that infinite sequence, one rise and fall in the heartbeat of the cosmos. When the black hole sleeps, the galaxies around it thrive. Stars form, light spreads, and life, if it exists, has time to grow. The silence that follows an eruption is not emptiness, but renewal. A long, slow rebuilding. In this way, the black hole's sleep is just as important as its awakening. One brings energy, the other brings balance. As you picture this, imagine the Ophiuchus cluster drifting in peace. Its galaxies glow faintly, surrounded by the soft warmth of gas. At the center, the black hole rests, unseen and unbothered, waiting for the next cycle to begin. Its last eruption may have ended billions of years ago, but its influence continues in every particle of light that moves through the cluster. Even though black holes appear silent, the universe has ways of whispering when one is about to wake. Astronomers have learned to listen for those whispers, to notice the faint signals that hint at growing hunger deep within the heart of a galaxy. A sleeping black hole does not remain still forever. It stirs slowly, gathering matter, reshaping its surroundings before the next great release of energy begins. In the Ophiuchus cluster, scientists have already begun to detect these signs. Tiny variations in the flow of gas near the center, faint ripples of heat, and delicate twists in magnetic fields. These may seem like small things, but in cosmic terms, they are the first breaths before the storm. The black hole, once calm, begins to feed again. Gas that has drifted for millions of years finally falls inward, drawn by gravity's pull. As it approaches the event horizon, it accelerates, heating until it glows with invisible light. If we could see this process unfold, it would look like a faint spark in the dark. The gas would spiral inward, forming a flat disk that grows brighter and hotter with time. It would begin to emit X-rays and radio waves, signals that telescopes on Earth could detect. Slowly, the region around the black hole would awaken, not with sudden violence, but with a growing hum of energy building towards something vast. Astronomers track these signs using powerful instruments like the Chandra X-ray, observatory and radio telescopes scattered across our planet. Each observation is a glimpse into a different layer of the process. X-rays reveal the heated gas. Radio waves trace the magnetic fields. Optical telescopes capture the faint motion of stars being pulled by invisible hands. Together, these data form a picture of a giant returning to life. What they find is both predictable and full of mystery. Every black hole follows the same pattern of feeding and resting, yet no two eruptions are identical. Some awaken gently, releasing streams of radiation without disturbing their surroundings. Others, like the one in Ophiuchus, erupt with force that can change the structure of entire clusters. The difference depends on how much matter the black hole consumes, how fast it spins, and how strong its magnetic fields become. In Ophiuchus, those conditions once aligned in a perfect storm. Now, as gas begins to drift inward again, scientists wonder if history will repeat itself. The signs suggest the black hole is still active, though much quieter than before. It may take millions of years before another explosion occurs, a timescale beyond human comprehension. Yet, in cosmic time, that is just a moment's pause. Understanding these awakenings helps astronomers see how the universe evolves. Every flare of energy, every eruption, every silent period in between adds to the grand design of the cosmos. The balance of heating and cooling keeps galaxy clusters stable. The rhythm of sleep and awakening ensures that creation never stops. The Ophiuchus black hole, like others across the universe, plays its part in that endless cycle. It is strange to think that such enormous power can be so patient. For now, The black hole's hunger is quiet. It feeds slowly, taking in only what drifts too near. But deep inside, near the event horizon, energy builds. Magnetic fields twist tighter. Light begins to swirl and fade as gravity bends it beyond recognition. The universe prepares for another act in its timeless performance. Perhaps, in some distant future, astronomers will once again see the signs. A faint flare in X-rays, a sudden glow in radio waves, a ripple of pressure moving through the cluster. When that happens, they will know that the giant has awakened once more, ready to breathe out another wave of creation and destruction. The greatest mystery of black holes lies in contradiction. They are the most powerful objects in the universe, yet they emit no light of their own. They can unleash energy greater than entire galaxies, yet they remain completely silent. Their nature is a paradox, ultimate gravity locked in perfect stillness. The Ophiuchus black hole embodies that paradox more clearly than almost any other. Its eruption changed the structure of space across millions of light years. Yet at the center of it all, there was nothing visible. No sound, no glow, no trace of the power within. To understand this contradiction, one must imagine the boundary where everything changes, the event horizon. This invisible surface marks the point beyond which nothing, not even light, can escape. Matter that crosses it is lost forever, pulled into a singularity where all known laws of physics break down. Yet just outside that boundary, energy gathers and transforms. Here, in this thin layer between existence and oblivion, the universe's most extraordinary processes take place. As gas spirals toward the event horizon, friction and magnetic turbulence tear it apart. Every particle crashes against another, heating the disk until it glows with energy. It shines in X-rays, in radio waves, in invisible forms of light that spread across the cosmos. But the light does not come from the black hole itself. It comes from the struggle at its edge, from the last desperate resistance of matter before it disappears. The black hole, by simply existing, turns gravity into radiation, silence into motion, darkness into light. During the Ophiuchus explosion, that paradox reached its most extreme form. The black hole was consuming so much matter that it could no longer remain still. Its magnetic fields coiled tighter and tighter, building pressure until they snapped, releasing energy outward through the jets. What we call an explosion was not fire but transformation. Gravity converted into light, motion, and heat on scales no star could match. And yet, in the midst of that cosmic eruption, the black hole itself remained perfectly quiet. No matter how much power it released, it made no sound. Its center stayed black, absorbing all that came too close. Even as it reshaped the cluster, it never revealed its face. That is the paradox that defines it. The calm at the heart of chaos, the silence that holds the universe's loudest voice. This silence is not emptiness. It is balance. Inside the event horizon, time and space fold in on themselves. From our perspective, everything slows down near that edge. Light bends and fades, motion freezes, and the flow of time appears to stop. To an outside observer, matter falling into a black hole never truly disappears. It simply becomes slower and dimmer until it vanishes from view. The black hole's quiet is, in a way, an illusion born from time itself. What makes this so powerful is the lesson it holds about the universe as a whole. The same forces that destroy also create. The same silence that hides darkness gives rise to light. The Ophiuchus explosion was a demonstration of this truth, that peace and violence, stillness and energy are not opposites but parts of the same whole. If we could stand near the edge of the Ophiuchus black hole, impossible as that is, the view would be beyond imagination. The stars of the cluster would curve and stretch, their light bent by gravity. The accretion disk would glow like a ring of fire, swirling faster than thought. Beyond that, there would be nothing. No sound, no light, only infinite depth. And yet from that depth, energy would be streaming outward, touching galaxies millions of light years away. This is how the universe speaks, not in words, but in balance. Every force has its opposite. Every silence hides a sound. Every darkness conceals light. The Ophiuchus black hole is one of the purest expressions of that harmony. Every galaxy carries the mark of its black hole. Though invisible, these cosmic engines shape everything around them. The flow of gas, the rhythm of star formation, the balance between chaos and calm. They are not merely residents of galaxies. They are their architects. The Ophiuchus explosion revealed just how deep that influence goes, showing that even one black hole can sculpt the fate of billions of stars. When astronomers look at galaxies across the universe, they find a striking pattern. The mass of a galaxy's central black hole is directly connected to the size and behavior of the galaxy itself. This relationship suggests that black holes and galaxies grow together, each one influencing the other. The black hole feeds on the galaxy's gas, while the energy it releases in return shapes how the galaxy evolves. The two are locked in a cosmic partnership that defines the very structure of the universe. In the Ophiuchus cluster, this relationship can be seen on a grand scale. The explosion that tore through the cluster did not destroy it. It organized it. The shock waves redistributed the gas, preventing runaway star formation and stabilizing the cluster's temperature. The galaxies within it continued to shine, balanced between creation and stillness. It is as though the black hole acted as an unseen architect, using energy as its blueprint, pressure as its tool, and time as its canvas. To model these effects, scientists use powerful simulations that trace the motion of gas and energy across billions of years. In those digital universes, they see how a single outburst from a black hole can ripple outward, changing the growth of galaxies far from its center. They watch how jets carve channels through the gas, how heat spreads evenly, and how balance returns after each eruption. The results match what telescopes observe: galaxies shaped not just by stars and gravity, but by the hidden influence of black holes. This discovery has changed how we understand our own cosmic home. At the center of the Milky Way lies a black hole much smaller than the one in Ophiuchus, yet it too has shaped our galaxy's life. The stars near its core move under its gravitational pull. The gas clouds that form stars are stirred by its presence. Though it is quiet now, it has likely awakened before, sending small jets of energy that rippled through the galactic center, keeping the balance between order and chaos. The Ophiuchus explosion offers a glimpse of what might one day happen again in our own galaxy. Perhaps far in the future, when enough matter gathers near our central black hole, it will flare once more, sending waves of energy across the Milky Way. It will not destroy, it will renew. The pattern will repeat, just as it always has: destruction feeding creation, silence giving way to sound. When we see galaxies glowing in the night sky, we are seeing the results of that balance. Their beauty, their shape, their light, all of it is guided by the quiet work of black holes. The stars we see are like the stones of a great cathedral, but the design comes from the architects hidden within their hearts. Without those unseen forces, the structure would collapse. With them, it endures. What makes this even more humbling is that every element in the universe, even those that make up us, has been touched by this process. The oxygen we breathe, the carbon in our cells, the iron in our blood, all were created in stars shaped by cycles of energy that began in the depths of black holes. The same balance that builds galaxies builds life. So when we look at the Ophiuchus cluster, we are not just seeing a distant explosion. We are seeing the design of the universe itself, vast, patient, and full of purpose. The black hole at its center is not a destroyer. It is an artist, a builder, a silent architect working with the raw materials of gravity and time. The universe, when seen from far enough away, looks like a great woven web. A network of galaxies connected by thin strands of matter and energy stretching across infinity. Astronomers call it the cosmic web, and it is the largest structure ever known. Galaxies gather at the intersections of these strands like glowing beads of light. Within those galaxies, black holes sit at their centers, shaping them just as the web itself shapes the universe. The Ophiuchus cluster is one of those glowing knots in the web. It sits within a strand of matter that stretches across billions of light years, part of the framework that holds the cosmos together. The explosion from its central black hole did not stay confined within its own cluster. Its energy rippled outward, mixing with the thin gas that fills the vast spaces between galaxies. These ripples may be faint, but they add to the background hum of the universe, the constant low vibration of energy that moves through the cosmic web. Every black hole that erupts, every galaxy that breathes, every supernova that dies contributes to this web. Their energy connects across space, balancing gravity with motion, light with darkness. When scientists study the large-scale structure of the universe, they find patterns that mirror the flow of energy in the Ophiuchus cluster. Waves and filaments, intersections and voids, each shaped by the invisible influence of black holes. What makes this connection so remarkable is that it links the smallest and the largest forces. The same gravity that pulls a single grain of dust to the ground also binds galaxies together across the universe. The same balance between creation and destruction that shapes the Ophiuchus cluster shapes the cosmic web itself. The laws of nature do not change with scale. They repeat, weaving harmony from simplicity. Through computer models, astronomers have simulated this web of power. They watch as galaxies form along filaments of dark matter, as black holes ignite at their centers, as waves of energy move outward. The result looks like veins of light pulsing through darkness, a living map of the universe's growth. Each bright point is a cluster like Ophiuchus, glowing because of the heat and energy that black holes release. Without those outbursts, the web would be cold and still. With them, it shines. The black holes, in this sense, are the engines of the cosmic web. Their explosions feed energy into it, keeping the flow of matter and heat alive. They are both anchors and catalysts, ensuring that the universe remains dynamic. Even when they rest, their influence persists, holding galaxies in place like the knots in a vast tapestry. The light from the Ophiuchus explosion now travels through this web, crossing endless distances. Along the way, it bends around other galaxies, passes through clusters, and merges with the faint background glow of radiation that fills all of space. That glow, known as the cosmic background, is the memory of creation, the leftover light from the beginning of everything. The energy from black hole eruptions adds subtle patterns to it, small ripples that tell the ongoing story of a universe still in motion. In this way, the Ophiuchus explosion becomes more than a local event. It becomes a part of the universe's long conversation with itself. The energy released there influences everything connected to it, however faintly. Like a note in a symphony, it blends with countless others to create the sound of existence. When you imagine the cosmic web, picture it not as still lines of matter, but as living energy, waves of light and gravity flowing between galaxies. Every pulse of a black hole, every star that shines, every explosion that fades away contributes to this endless movement. It is the heartbeat of the universe, and we are part of it. The universe has been expanding since the moment it began. Every galaxy, every cluster, every particle of light is moving away from every other, carried by the stretching fabric of space itself. This motion defines the shape of everything, and yet it raises a question that has haunted scientists for generations. Will it continue forever, or will it one day slow, stop, and reverse. The Ophiuchus cluster, like all great cosmic structures, moves within that expansion. Its galaxies drift apart, though the gravity within the cluster still binds them together locally. From our perspective, it seems stable, calm, unchanged. But on the scale of billions of years, it too is carried outward by the flow of the universe. The light we see from its explosion began its journey when galaxies were closer together, when space itself was younger and denser. Now that same light travels through a universe that has grown vast and cold. To understand the future of that expansion, astronomers study events like the Ophiuchus explosion. These eruptions reveal how energy moves through the universe, how heat spreads, how gravity pulls, how pressure balances against emptiness. Each explosion is a tiny reflection of the greater story. A burst of creation followed by calm, a balance between expansion and rest. For most of cosmic history, gravity and expansion fought for dominance. Gravity tried to pull everything back together, while expansion kept pushing it apart. For a time, they were nearly equal. But then, something began to change. The expansion started to accelerate, as if an invisible hand were pushing the universe outward faster and faster. Scientists call this mysterious force dark energy. It's space itself, growing stronger as the universe expands, and it may decide the ultimate fate of everything. If dark energy continues to dominate, galaxies like those in the Ophiuchus cluster will drift farther apart until even the light between them fades. The cosmic web will stretch thinner, its filaments weakening, its bright knots growing lonely. In that far future, each cluster will become an isolated island in a sea of darkness. Black holes will remain, feeding slowly on what is left, glowing faintly as they release their last bursts of radiation before fading into silence. But there are other possibilities. If dark energy weakens, gravity might one day reclaim its strength. The universe could slow down, and expansion might stop. Then perhaps it could begin to contract, pulling everything back together in a grand reversal, a cosmic return to unity. Some call this the Big Crunch, a future where all the galaxies, all the stars, and even black holes fall back into one infinite point, as they did at the beginning of time. Whichever fate awaits us, the Ophiuchus explosion gives us clues about how the universe handles balance. Even in its most violent acts, nature restores equilibrium. Every burst of energy spreads heat that prevents collapse. Every wave of gravity keeps structure bound. It may be that this same principle applies to the universe itself, that it will find balance not in stillness, but in endless motion. If the universe continues expanding, it will not end in destruction, but in transformation. The galaxies will grow quiet, stars will fade, and black holes will rule the dark. But the energy they release will never truly vanish. It will spread, thin and cold, across eternity, carrying the last whispers of creation into infinite space. And somewhere within that silence, the echoes of the Ophiuchus explosion will still drift, stretched beyond recognition, but never gone. Every photon, every ripple of heat, every trace of motion will remain part of the grand balance that began when the universe itself took its first breath. When you look at the night sky, you are seeing this story in motion. The light from distant stars is not just beauty. It is proof that expansion continues. Every star you see is a moment in that journey. Light traveling through a universe that refuses to rest. Time to us feels like a river, moving steadily forward, carrying every moment away. But in the vastness of the universe, time does not flow the same everywhere. It bends, it stretches, it slows. Around black holes, it becomes soft and heavy, and across the expanding universe, it stretches like the surface of an endless balloon. The Ophiuchus cluster and the explosion at its heart reveal this hidden nature of time in ways that words can only begin to describe. When the great eruption occurred, space itself was younger. The universe had not yet expanded to its current vastness, and time moved differently. Light that left that event began a journey across billions of years, traveling through space that was constantly changing beneath it. The light we now see is ancient. It carries not only information about what happened, but also about how time has flowed since then. Einstein's theory of relativity tells us that time and space are parts of the same fabric. When mass bends space, it also bends time. A black hole, being the most concentrated mass possible, warps time around it so deeply that for someone falling toward it, the universe would appear to speed up infinitely. To distant observers, that person would seem to slow down, fading away just before reaching the event horizon, never quite vanishing. In this way, a black hole is not just a place in space. It is a place in time. The Ophiuchus black hole holds within it a moment that may never pass. To us, the explosion it caused is history, long over. But near its event horizon, the process of that explosion may still be unfolding, frozen in time's deepest gravity. What we call the past might still exist there, suspended forever in light that will never escape. As the universe expands, time itself stretches. The further light travels, the more it slows in rhythm. This stretching turns the sharp flash of an explosion into a long, soft glow. The reason why we can still detect the Ophiuchus event today. Its light has been pulled across time, lengthened until it became a whisper. What was once a burst of power now moves through space as a calm vibration, a reminder that even the greatest forces fade gently in the end. To us, billions of years seem infinite, but in cosmic terms, time is just another element, like gravity or energy. The black hole that caused the Ophiuchus explosion does not experience time as we do. To it, moments blur together, feeding, erupting, resting, all part of one long rhythm. When it sleeps, time barely passes. When it awakens, time bends to its will. And its gravity is so strong that even the ticking of the universe slows near it. In the larger view, the expansion of the universe also changes time for everything. As galaxies drift apart, their light grows older before it reaches us. This means that when we look at the Ophiuchus cluster, we are not seeing it as it is, but as it was. Every image is a memory, a glimpse into an age long gone. The light entering our eyes tonight began its journey before the earth existed, before life had taken its first breath. And yet, that light still arrives. Time, though stretched, does not break. It carries every story forward: the birth of stars, the death of galaxies, the silence after an explosion. The universe holds all of it at once, past and present entwined like threads in a single tapestry. If we could see that tapestry as a whole, time would not look like a line, but like a landscape, peaks and valleys shaped by gravity and motion. The Ophiuchus explosion would be a mountain, a place where energy and time collided, leaving a mark that endures forever. The flow of cosmic time is slow, patient, and unstoppable. It changes everything but forgets nothing. The light from Ophiuchus still travels, the cluster still drifts, the black hole still rests. And as we watch, we are reminded that even in eternity, time has its own beauty. Not in speed, but in endurance. One day, the universe will grow quiet. The stars that burn now will fade, their fuel exhausted. Galaxies will dim, and only the faintest glow of scattered radiation will remain. But even then, traces of ancient power will drift through the dark. The ghosts of explosions, like the one in Ophiuchus, still moving through space, their light stretched into soft waves of memory. The Ophiuchus eruption was not a brief spark. It was a mark written into the structure of the universe. The shock waves it created continue to ripple through the gas of its cluster, and the energy it released continues to flow outward. Even after billions of years, that energy will not vanish. It will fade, yes, but it will never truly die. In a sense, it becomes part of the fabric of space itself, woven into the background radiation that fills every corner of the cosmos. When scientists look at the cosmic background, they see faint variations, tiny differences in temperature and energy. Each one tells a story. Some are echoes of the universe's birth. Others the remnants of galaxies colliding or black holes erupting. Among those whispers are traces of explosions like Ophiuchus, still carrying information across the expanding void. As time continues, those whispers will stretch thinner, their wavelengths growing longer. What was once a powerful burst of energy will become a slow pulse of warmth, barely detectable, but still there. The last observers of the universe, if any exist, may not see the galaxies or the stars, but they might still sense this warmth, this faint hum of ancient creation. It will be the final light of a cosmos that refuses to disappear completely. In that far future, black holes will rule the dark. They will consume the last of the stars, the last of the gas, and then begin to fade themselves. One by one, through an unimaginably slow process, they will release their energy into space as a fine mist of particles and radiation. Even the Ophiuchus black hole will someday do this, its power dispersing, its gravity softening, until it becomes light once more. That moment will mark the universe's quiet transformation, not its end. The matter and energy that once formed galaxies, stars, and people will spread evenly through space, a perfect balance of silence and motion. There will be no explosions then, no heat or light as we know them, only the smooth rhythm of the cosmos breathing its final breath. But in that calm, the story will still be present. The light from the Ophiuchus explosion will still drift, endlessly faint but unbroken. Every burst of energy that ever existed will still move forward, each photon carrying the memory of where it began. The universe will not forget its past. It will carry it everywhere, in every vibration of space, in every echo of light. Perhaps this is the true beauty of creation, that nothing is ever truly lost. Energy transforms, matter changes, but existence continues. The black hole that once erupted so fiercely will one day fade, and yet its story will remain, written in the soft glow of eternity. If one could float through that far future, among the ashes of galaxies and the remnants of stars, the silence would not feel empty. It would feel full of everything that once was. The faint hum of ancient light would be the sound of memory itself, the quiet voice of the universe saying that every act of creation, no matter how brief, lasts forever. And even in that final calm, the Ophiuchus explosion, the most powerful ever recorded, will still exist as light. Not in brightness, but in presence. Not in fire, but in warmth. A single ripple in the infinite ocean of time, still moving, still alive. The story of the Ophiuchus explosion is more than a tale of power. It is a reminder of balance, of how the universe holds creation and destruction in the same hand and calls them by the same name. From the deepest darkness came light, from silence came motion, and from collapse came renewal. The black hole that caused it did not act in chaos. It followed the quiet law that governs everything, the rule that nothing exists without balance. When that black hole released its energy, it did not do so to destroy the galaxies around it. It did it to restore harmony, to spread heat and motion where stillness had begun to gather. That act, though violent in scale, was part of a rhythm that repeats everywhere. Stars are born. They burn, they die, and their ashes form new stars. Galaxies collide and merge, spreading light and dust, that will one day shine again. Even black holes, which seem eternal, give back the energy they once took. The universe does not waste, it transforms. In that way, the Ophiuchus explosion is a symbol of the universe itself, vast, patient, and wise. It reminds us that endings are never final, that what seems lost only changes form. The energy that left that cluster billions of years ago now moves through space as faint light, touching worlds and eyes that did not yet exist when it began. We too are part of that story. The atoms that form our bodies were once part of stars, shaped by explosions like the one we have followed tonight. The balance that keeps galaxies alive also lives within us. If you close your eyes and imagine the Ophiuchus cluster as it is now, you might see a quiet expanse of light and shadow. The stars drift, the gas glows faintly, and at the center rests the black hole, still, patient, dreaming. Around it, the remnants of the great explosion continue to move, their energy softened into peace. The violence is gone, but its purpose remains, carved into the shape of the cluster like an artist's final stroke. And beyond it all, the universe continues to expand, its rhythm unbroken. New stars will form, new black holes will awaken, and new explosions will echo through the darkness. Each one will carry the same message, that the universe is not a place of destruction, but of endless renewal. Every death is a beginning. Every silence hides a song. Perhaps that is why looking at the night sky brings such calm. In the cold light of distant galaxies, we are seeing the universe remembering itself. Every point of light is a story of balance, a memory of motion that has never stopped. The Ophiuchus explosion is one of those stories, a reminder that even the most powerful forces in existence serve the same quiet purpose, to keep the cosmos alive. So as you drift to rest tonight, think of that faraway cluster and the silent black hole at its center. Think of the waves of energy still moving through the dark, their journey unending, their message eternal. The universe breathes through them, steady and calm, reminding us that we are part of something that never truly ends. Because in the end, there's no end. There's only balance, light and darkness, silence and sound, creation and rest, all moving together through infinite time. And somewhere, in that harmony, the echo of the most powerful black hole explosion ever recorded still glows, whispering softly through the fabric of the stars.